In this little movie I'm going to compare the industry standard for dynamic simulation, which is Simulink, to Minsky. First of all, just as a way of designing a standard system dynamics model, and I'll use the simple Goodwin model for that basis. And the Goodwin model, which is the basis of my economic modeling in general, has a basic flowchart that starts in saying if you have a certain level of capital stock, that will determine the amount of output that you can generate. With the amount of output you can produce, that then determines how many workers you need to employ. The employment rate comes out of that, and that then gives you the rate of change of the wage rate. And then if you take the wage and multiply that by labour, you get the wage bill. If you subtract that from output, you get profit. And assuming, as Goodwin does in the simple model, all profit is invested, that gives you the rate of change of capital, and that takes you back up to this point again. So I want to illustrate how we design that in Simulink, and then how that compares to Minsky. The main purpose that Minsky has been designed is not to emulate or to improve upon an existing program like Simulink, but to do something that's very, very hard to do in those, which is model the financial flows, but I'll show that in a later part of the video. Now this is the design interface for Simulink, and I'll start building the very beginning of the model, but I'll then go across to completed versions to save time. So to build a model, what you first of all have to do is to bring across various mathematical operators here, and the most important ones are the integration variables, which are shown as 1 over s here. So I bring this block across here, I'll drop it here, and I can then change the label and call this capital. And if I double click on the block and go inside, they can say, well, the initial amount of capital is, say, 300 units. And then I need to divide that by a constant which represents the capital output ratio. So I call this accelerator, the usual term for that, and give that a value of 3, etc., etc. Now to combine this together, as in all these programs, I use wires, and what I want to do now is divide that by divide capital by the accelerator. So I need to bring across the divide by block here, which I'm looking for. Can I spot it? Where is it? Many blocks, for obvious reason. A very, very complicated, very advanced program, lots of functionality, and I'm just being a bit of an amateur here, trying to spot the divide by key. There it is. Okay, divide by, and then you drag a wire from the top to there, and to the bottom to there, and you then have the beginning. I haven't quite got it there yet. You then got the beginnings of a model. So that's what you do. Now Simulink requires you to wire everything together. You can use numerical labels to drag things between different models, but normally it's just by wires. So I'll stop at that point and I'll show you the completed model in Simulink in the next part of the video. And here's the completed model in Simulink. I think it may look confusing when you first see it. Wait for it, you're going to see something much more confusing shortly. But let's go through it. First of all, here I have capital. Here's my accelerator. Divide capital by the accelerator and I get output. Then I divide output by labour productivity, and I'm saying here one worker produces 1 unit of output. And then I have the amount of labour that's needed to be employed. And then again, for the simple sake of illustration, a constant population. If you divide the number of workers you need to hire by the population, you get employment rate. Now I'm starting to run into crossing wires, and I've been emphasising that because you'll see the difference with Minsky in a moment. But I've now said let's subtract the actual employment rate from the Milton Friedman's fantasy of a non-accelerating inflation rate of employment, and that gives you the gap. These are all labels, by the way, just text labels to indicate what's going on. They're not actually variables, and I'll again explain why that's important when I show Minsky. That's the gap between the actual rate and the stable equilibrium rate. Multiply that by how much workers react to that. So I'm saying if there's a 1% gap in employment, there's a 10% demand for wage rises. That then gives me a Phillips curve, which I show here by this loop at this stage. Rate of change of wages multiplied by the current wage with this loop here. Integrated gives you the wage. Then I have the wage bill, which I subtract from output, which I'm dragging from way over here. This wire, which I'm running along now, brings output down to this point, so I can subtract the wage bill from output to get profit. And this wire then take me around to capital, and I've now completed the model. If I want to see it, I have to click the simulate button, and there's one of the plots. That's this one here, and there's the wage plot. This is the Minsky interface. Of course, it's much simpler than the Simulink, for the simple reason we haven't had anywhere near as much time or money to invest in developing the interface, but I think it's actually rather easier to use. Well, let's just illustrate that now. So I bring down an integral block here. This is the same as the 1/s block in Simulink. I can now name this capital, but it's actually giving a name to a variable, and that'll be very important when I wire up the entire model, particularly more complicated ones. There's capital, 300 units initially. I now want to divide it by a constant, which I'll call the accelerator, as in the model in Simulink. I need a divide by block. So it's bringing that down. So far I'm behaving in a very similar way to Simulink, and I'll just wire this one up. Still fine-tuning the wiring. We only just added the capacity to have context-sensitive wiring in the very last iteration, so we need to make it easier to reach that particular point. That's capital divided by accelerator. Now I could click on variable and type the word output here, but in fact if you simply type on the keypad, and we'll make that visible at some point as well as you're typing, then you can create the variable. And the same thing applies down here. If I make this, now I have labour productivity, and I'm being a bit fancy here because we support subscripts and things like that. I've stuffed it up by not being able to see it in typing. If I double click, I can now make this an underscore using the facilities that are built into the mathematical processing language called TeX. If I divide output by labour productivity, then I'm going to get employment, so I can type employment here. And I need a divide by block, so I simply press the divide by key here. And then on I go with the rest of the model. And I can also, if I want to have the employment rate, which I need to have divided by population, so I'll type population here, and then a divide by block here, then I can now say this is equal to the employment rate, and I can use the Greek letter lambda for that, and then I wire that together, and I'll show the completed model in a moment. This is the completed model in Minsky, and I want to illustrate a couple of points about it before I run a simulation. First of all, notice that there are no wires that are crossing other wires, because rather than having to drag output from a wire from here right down to over here to determine the rate of profit, I can simply type the variable name down here, output there, so there's no need to wire, and you actually have to do in Simulink. Just show you that look like again. There's a Simulink relationship, and I've got to take the wire from here down to here, unless I want to use a numbered variable, the 0, 1, 2, 3, 4, 5, 6, etc., which, of course, in a large diagram, what does 0 stand for? What does 1 stand for? You'd forget. So the flow is much more obvious. Here we have capital divided by the accelerator's output, divided by labour productivity is employment, divided by population is the employment rate, Greek letters, which again we can do in Simulink and all the other programs cannot. The Phillips curve reaction, output minus wages becomes profit, becomes investment, back to the beginning again. That's one detail. Second detail, note that graphs are actually embedded in the surface of the diagram, whereas here with Simulink you see what are called plot variables, but to actually see what's going on inside, you have to double click before you'll actually see it. And if you run the simulation, which I'll do now, then you see it after you've done the simulation. You don't see it before while it's actually running. However, in Minsky, if I hit the simulate key, then you see the cycles taking place there. I've made a mistake with lambda over here, but I'll check that out later. So that is the very, very simple interface we have. I think much easier to design with than with Simulink, and you can actually see the simulation while it's running dynamically, and I'll compare next the major difference between the two programs, which relates to this element up here we call the Godley Table, which lets us model the financial system, because this is of course an extremely simple model with no bank in it, no financial system. When you start adding the financial system and trying to model a capitalist economy in more of its complete detail, then it gets to be an extremely complicated process to use flowcharts to do that. Very straightforward with Minsky, and that's why we designed it in the first place. This is clearly a much more complicated model, and it would take quite a while to explain it, but as you can see there's still the same basic flow structure obvious here, and over here we have the Godley Table that lets us model the financial flows. So what I'm showing here is lending for investment, servicing of debt, payment of deposit interest to workers and capitalists, hiring of workers, consumption by workers, consumption by bankers, and repayment of debt. And that table there lets us make, for example, if I want to add an extra element inside here, I can simply add, for example, microfinance or something of that nature and add that and add operations over here. But I won't show that. I'll just show you the comparative diagram. So that's what it looks like in Minsky. What does it look like in Simulink? The fact that the wires, two things. First of all, the fact that the wires have to be used to connect one variable to another makes it, I think, effectively impossible to work out what is the logic behind this particular circuit, even though the two models are formally identical. Secondly, you can't see the financial structure because somewhere embedded inside here, this is the level of real capital, this is the rate of profit over here. The banking sector is embedded somewhere in that diagram, whereas here, that is the banking sector. And of course, if we wanted to add, as I mentioned a moment ago, add an extra element like, for example, let's say sharecroppers, and have payment of rent to landlords, and add landlords inside here, etc., etc., then it's very easy to add those elements to the structure. And if you want to see the system from the point of view of a different group in society, so you want to see this, for example, from the point of view of, let's say, of the landlords, then you can take a look at their financial table as well. And a very, very advanced financial system can be modeled with multiple banks showing the central bank, private banks, microfinance, etc., etc. Straightforward to do in Minsky. I believe there's no problem in asserting it would be impossible to do that in Simulink. And this is one of the major reasons why system dynamics hasn't penetrated into the economic space for non-orthodox economists on a grand scale as yet, because when they attempt to model the financial system with a program like this, or even worse with Vensim, which I think has got a more complicated interface still, they simply have to give up. It's just too hard. Minsky has been designed to make it easy.